Problem number 4. So I have a triangle. I've got an angle. I've got a couple of sides. I want to find all possible values for beta. Let's see which of our situations we have here. So I have an angle of 25 degrees. There's my angle alpha. I have this side length here of 22. And then coming off over here, this must be side A. Side A has to be opposite angle alpha. Angle beta is this angle right here. Well, this is that tricky scenario. This is that SSA situation, two sides and not the angle in between. So this is the one where you have to be really careful because it's possible that this 17 side that I drew here might also be able to be drawn over here, resulting in two triangles. We'll have to see as we do the math. We'll set up the law of sines. So I have sine 25 degrees over 17 equals sine beta over 22. I'll get sine beta by itself by cross multiplying. So I'll have 17 sine beta is equal to 22 sine 25. I'll divide both sides by the 17. And so now I have sine beta equals that number over there. Here's where things get tricky, right? It's probably a good idea for me to find what this ratio is on the calculator. So let's type that in. 22 sine of 25 degrees divided by 17. So the ratio comes out to be around 0.55. That makes me think I might just get two answers here, because if I want to solve that equation, I know there's a first quadrant angle, 0.55 over 1, and then there would be a second quadrant angle, also 0.55 over 1. I can use sine inverse to find me this little piece, but then to find this angle here, I'll have to use the symmetry. I'll have to do 180 degrees minus the first piece. So I think what we're saying is potentially we've got beta 1 is sine inverse of that 0.55 number. Of course, we'll use the whole long thing in the calculator. And then beta 2 is going to be 180 degrees minus that first little angle. So let's see what's going to work out here. Sine inverse of that last answer, that 0.55 number, that comes out to be 33.2 degrees. So there's one possible value of angle beta. The other one, according to my picture, would be 180 minus that. 180 minus the 33 number comes out 146.8 degrees. Now, is that a possible answer? I think it is, because my first angle is 25. If I add 25 onto this, I'm going to get about 171.8. That's still under 180, so that still means I could form a triangle. So I actually have two possible answers here for angle beta. In other words, this situation is exactly what happened. There's two possible triangles that can be formed from the given information. Problem number 5, I want to find theta and I want to find c. We're working in degrees here. So when I look at part A, of course for c, I can just use the Pythagorean theorem. It would be 5 squared plus 2 squared equals c squared. That's 25 plus 4 is 29, and so c, of course, will just be the square root of 29. We want decimals, so we'll go to the calculator, and that comes out to be about 5.4. For theta, I'll have to use some trig. I always like to use the values they gave me if possible. So it looks like a tangent ratio would make sense. Tangent theta here would be 2 over 5. That's a right triangle. So theta would just be the inverse tangent of 2/5. Inverse tangent 2/5. And that comes out to be about 21.8 degrees. The second picture is a little trickier. I'm not in the first quadrant anymore, but I think what I would probably do is just treat this as a regular right triangle. In other words, ignore the negatives, just work with it as a 2, a 6, and a C. And I know I want that really large angle there, but I think I'll just find this angle here since it's in the triangle. And I can see to get my large angle, if I just did 180 plus that red angle, I'll have what I want. So let's start with the C. That's just going to be Pythagorean. 2 squared plus 6 squared equals C squared. That's 4 plus 36 makes 40. I will do the square root. I can simplify the square root of 40, but I want a decimal, so there's no point in doing that. I'll just go to the calculator and grab the decimal from there. Square root of 40 is about 6.3. And then remember, I'm not going to worry about angle theta right now. I'm going to worry about this little angle here. How about I call it angle alpha? Again, I'm ignoring all the negatives and positives. I'm just treating this as a regular right triangle. I can write another tangent relationship using that angle alpha. Tangent alpha would be opposite over adjacent, 2 over 6, or 1/3, which means alpha would just be tangent inverse of 1/3. Tangent inverse 1/3 comes out to be about 18.4 degrees. Now we're not saying that's the final answer. That was just this little red angle here. To get my angle, to get theta, I would just have to take 180 plus angle alpha. In other words, plus that 18.4. When you add that on, you're going to get 198.4 degrees. That's the angle I wanted, angle theta, in this picture. Problem number 6. I want to find the coordinates of this point P that's shown here in the picture. The first example is pretty simple because I can see I've got a 30, 60, 90 triangle, and I know how those work. The hypotenuse is always twice as much as the smallest side. The smallest side goes across from the 30. So this has got to be 25, right? 30, 60, 90, it's always x opposite the 30. 2x is the hypotenuse, and then x root 3 is the 60-degree side. We usually use 1, root 3, and 2, but this is the more general version. Well, if the short side is 25, that means the medium side is 25 root 3. Do I have any negatives here? The x is obviously positive. The y in the fourth quadrant would be negative. And that's all I need. The directions say we want an exact answer here in part A. Well, here it is. 25, comma, negative 25 root 3. That's it. What about part B, where I don't have one of our special triangles? Well, I'll have to rely more on trig ratios here. Now you've got a couple of choices. I'm not in the first quadrant, so that 24 degrees really isn't the first quadrant angle, 24 degrees. That's a reference angle. Now you can work with that as long as you just work with the side lengths and then think about the positives and negatives later. Can I set up some trig ratios here? Sure. What if I call this A and I call this B? Well, I know that sine of 24 degrees then would be equal to B over 97. To get B, all I would have to do is multiply both sides by 97. 97 sine 24 gives me B. 97 sine 24. B is about 39.5. Okay, how about A? Well, just set up a cosine ratio. Cosine of 24 degrees would be A over 97. Again, clear the fraction, and you've got A, multiply both sides by 97. 97 cosine 24. I'll type that in, and then that comes out to be 88.6. Now, here's where you got to be careful. We were just working with a triangle. We weren't thinking about quadrants. Obviously, in the second quadrant, this A distance is in fact a negative number. So if you want to write down the coordinates of this point P, you'd have to use negative 88.6 because you're clearly moving to the left, and then positive 39.5. So there would be the final answer. If you don't like that, the other option we could have done is used the actual angle here. I'd have to go 180 minus 24. That's going to come out to be 156 degrees. If you had used that angle in your calculations instead of the 24, your signs, SIG and S, would have come out correctly. Take a look in that last calculation. If I type in 97 cosine 156, then it correctly comes out negative 88.6 because now I'm using the actual name of that angle. Either way is fine, you just have to make sure you, of course, get the correct answer.